Everybody got that answer?
Yeah.
So you have it exactly how I have it on the board?
Yeah.
No?
No?
I got a little confused. Sydney's stealing my thunder this morning. Hey, take a look here. If you have for an answer what I have on the board, you're 100% wrong.
Yeah, but
Why are you 100% wrong?
got the MG and the CL.
There are no units here. You have to have units. If we do not have units, you are 100% incorrect. No discussion whatsoever. If you had this on your quiz and you threw this at me, guess what I would do? I'm marking it wrong all day. Wow, Mr. Hall, you're mean. No, I'm preparing you. You have to have units. Proper units are grams per mole. Which brings me to something very exciting today. Today in this class we take a turn.
Huh?
We've done average atomic mass. How do you guys feel about calculating average atomic mass?
Yeah.
Do not forget how to do this. This will come back, okay? I have some of y'all that are super quiet, like to yourselves in here. And you kind of just sit there like, no reaction. Today we take a turn, but it's a good turn. It's a challenging turn, but it's one that is super important. To do this, I need you to understand that I'm taking valuable instructional time to stress this to you. What I'm getting ready to show you is super important, and you will use this throughout my class. Not only are you going to use this throughout my class, but it'll be something that you're going to take and love at college.
Really? You're not lying to me, Mr. Alright.
Everybody, it's a plain white piece of paper. I'm giving you this for you to build something on that I'm going to build with you.
Really?
If you're ever going to go somewhere in life, you typically look and say that if I'm going to go somewhere, you need a map. And I know what you're going to say. We don't use maps anymore. Yeah, we do. It's just on our phones, and they speak to us. What we're going to do today is we're going to build a map. This map is very important for a certain concept. A concept that will come back in this class multiple times. What this is called is the mole map. Mole map is just like any map. We can use this to go from one direction to another, from one destination to another. And on the mole map, there are 4 destinations that we look at. First one is mass. Second one is a very special one called the mole. Fourth has many. It's called atoms, molecules, particles, formula units.
Good.
And the last one is a very tricky one that I love to use. And you'll find out probably tomorrow why it's one of my favorite ones and I love to use it. My friend, volume. Now I've put a lot of space between all these for a reason. We're going to fill these things up. what I have on the board here in black, these are the destinations that we go to. The key thing I need you to take from this before we do anything is in the name. It's there for a purpose and it's there for a reason. Mole. The mole map deals with mole conversions. I've literally started taking a whole day in my chemistry classes to give a mole map because kids, I've learned some kids are just visual and they like to visually see something. So whenever we look at the mole map, it's the key concept and a key piece to help you with doing mole conversions. You don't have to use the mole map, but I give it to you for you to use. So with the mole map, the centerpiece, the center location is mole. Perfect example. There's always a center location. Center place you can go through. If I look and I want to go to Beckley, can I leave Oceana and get to Beckley? Yeah. Is there more than one way to go? Yeah. The mole map's most important feature is you have to understand everything goes through the mole. And I mean everything. These are called mole conversions. If mole does not show up somewhere within your conversions, you are wrong. Doesn't matter how you break it. So, I want to give you some information and show you where information will come from and things of what we'll use. Perfect example. You don't need to pull it out, but we need a piece of information for the first one. There we go. On a periodic table, it holds many, many pieces of information. Many of them. But the perfect example is, what did you just figure out how to solve for? We did it on Friday and I had you do it starting this morning. We solved for the average atomic mass. The average atomic mass is super important to us. The reason it's so important to us is because of how we're going to use it in relation to the mole. Average atomic mass, what were the units I told you?
Grams per mole.
Grams per mole. That is the unit for average atomic mass. And you're going to learn why it's so important. What's a perfect example of a unit for mass?
You got it, Commissioner.
Grams. Is that the only unit of mass?
No.
Hey, how about the International System of Unit?
Kilograms.
Kilograms. I got kilograms. I can do micrograms.
I like nanograms.
Gigagrams.
I love milligrams.
It's awesome, man. There are multiple different uses here. Here's the important aspect. Whenever you're going to go from mass to mole, so here's how I need you to look at this. Here's how I like to draw the mole map. At the top of it, I go from mass to mole. Your conversion factor is going to be set up like this, unit-wise. Where am I going? I'm going to mole, so there'll be 1 mole on top. And there'll be some number of grams on the bottom. I know what you're thinking. Holy smokes, where's the blank? Like, what goes there? Don't worry, I'll tell you in a second. Before I tell you that, I need you to see something. I can go from mass to mole just like I can go from Oceana to Pineville. Can I go from Pineville to Oceana? Yeah. So we can go from mole to mass. And what this will do is flip the unit. Where am I going? I'm going to mass. So there'll be some number, grams, and on the bottom will be 1 mole. What you'll see probably tomorrow whenever we start really busting into these guys is you're going to see a breakdown of how those are going to cancel units out.
So is this just like proportions in a way? You're using
Kinda.
fractions to make proportions?
But it's,
More
I don't
so-
think you guys has ever really done them before, but they're conversions. So it's things that are equal to 1, but it changes them into different units. So these numbers,
White Ford Fusion, you've left your lights on, parked in the upper end of the parking lot towards Baileyfield.
here's the important aspect. When using mass, well, let's not say that way, because that'd be confusing. When leaving or going to mass, must use the periodic table. Here's the reason as to why. Those numbers up there are the values off the periodic table.
That's what I'm talking about.
Or you will use the values of average atomic mass off the periodic tables to find it. Can I do it like this? Can I like quote that number and you know that I'm talking about this number up here?
Yeah.
Is that okay?
Yeah.
So I don't have to draw it up there. The number is an element's atomic mass or the molecule slash compound molecule slash compound molecular, I'll call it that, molecular mass. Mr. Hall, holy smokes, what is molecular mass? It's the mass of a molecule. It's the mass of a compound. So you see that and you don't freak out. You have no idea how to solve for this yet. Tomorrow we would do a Prof Bob that I showed you. Here's the other key piece that I need you to take from here. The units. And this is where you learn Mr. Hall no baiting you, okay? You learn why there are only 13 kids in Mr. Hall chemistry class this year. Because you were brave souls that you looked and said, I'll take the challenge. Or you looked and said, ah, man, it can't be that bad. Right now, you have done metric conversions and switched between the prefixes, and I've showed you needed to do it. I no longer show you need to do it. You have to notice it. This is the perfect example. the conversion factor is in grams. If you start with a mass not in grams, you must convert to grams. You have to see this now. I know you haven't done this before. You haven't had to catch it yourself, but that's okay, because guess what Mr. Hogg gonna do for you? Mr. Hogg gonna give you plenty of opportunities for you to do this. And I want to say this also, because I know a lot of you are probably coming in here and you're probably like, what in the world? You're probably gonna walk out here today having no idea what in the world's going on. Today's just about getting the MOMAP down. Tomorrow's when we put the MOMAP to use.
Will the unit always, will the base, will the unit always be grams, we just have to convert the prefixes, is that what you're saying?
Yeah. I'm sneaky in the way that I'll give you something in kilograms.
Is that the only way you can do it though? What if it's like a really, really big number and you have to like,
Yeah, do it
you just have to
one
be,
big
like if
number.
it's like a 2 trillion grams, you can't convert it to, bigger, decimal.
Could we convert, whenever we, set up our little ratio, could we change the prefix instead of making it like a base unit? Can we make it a certain number of kilograms to 1 mole, or would that change?
You can, but you're gonna make it harder if you're gonna worry about doing that. Easiest thing to do is change this first number. Now, if you're coming from mole to mass, you don't have to worry about doing a conversion, because it's already there for you. Where it's tricky is I'll give you mass and I'll start in kilograms. Like I'll go ahead and tell you tomorrow we're gonna do Prob Bob. I will start with a molecule in kilograms. The reason I do that is I want you to see, remember Prob Bob's belly of the beast. It's as hard as it can get. I'm gonna take you from mass, from kilograms to grams. I will do a molecule, so I'll show you how to calculate the molecular mass. Then we will take it to moles, and then I'll take it somewhere else. So that's mass.
That's what I'm saying.
Now, there's another side. I can go from moles to atoms, molecules, particles, and formula units. Here's the fun part with this. How do you know what unit to put? I'm going to make it very simplistic for you. I'll explain to you what each one of these are. Atoms are literally like just the element. So, atoms are the building block of matter. Molecules are biological molecules, stuff like that. So, stuff you've seen like carbon dioxide, sucrose, glucose, stuff like that's molecules. Particles are really super small. They're practically like atoms. Formula units are the special name for compounds. So like sodium chloride. They're not molecules, but they call them formula units. Dead giveaway to you. You're either going here because I asked you to, and how do you know that I asked you to go here? I asked you for a certain unit. Yeah.
Can I get a quick refresher on the difference between compounds and molecules?
Compound is ionically bonded, molecule is covalently bonded. We go through it back in this class
I
again.
remember that now, just woken, something like that brain.
So when you break this down, I will ask you to go here or I'll start you here. Don't freak out because there's 4 units here. I ask you in a question and that tells you the last unit to end with, or I start you with it. So just like over here, I can go from mole to atoms, molecules, particles, and formula units. And just like over there, I can go from atoms, molecules, particles, and formula units to mole. There is a special number that is associated with this. I'll show you the conversion factor, the unit breakdown, and then I'll give you the special number. I'll give you the abbreviation of it for now. I'm going from mole to atoms, molecules, particles, and formula units, which means one of these units will be sitting right here, because that's where I'm going, so that's where I'm trying to get to. And it has a very special number with it. It's abbreviation. It's a capital N with a sub-capital A. And on the bottom, where am I leaving? I'm leaving the mole. So 1 mole. Oh wait, why did I do that? I should not have done that. I'm so sorry, I should be in green. There we go. On the bottom, it's the reciprocal of it. So 1 mole on top, because we're going to mole, and then Avogadro's number on the bottom. And we have atoms, molecules, particles, and formula units. That's one of the units there. So when you break this down and you look at this, that is a very special number. This is called Avogadro's number. Kids have struggled to call it Avogadro. They're scared they're going to mispronounce it. So another way you can call it is what kids have came up with in the past is Avocado's number.
May I grab another piece of printer paper? I did this silly and I did a burger instead of a hot dog.
Can't you just flip it over?
It really don't matter. Avogadro's number is 6.022 times 10 to the 23rd. I'm leaving a blank here for units because guess what? It's 1 of 4. It can be atoms, molecules, particles, or formula units. There is one extra piece of information I stress with you when it comes to this.
Oh my goodness, stop it.
Avogadro's number is not equal to sodium. This is an abbreviation for Avogadro's number. This is the chemical symbol for sodium. Mr. Hall, why in the world do you stress that to us? I stress it to you because when I was a TA at Marshall, we had a lab that they were doing some stuff with Avogadro's number. And when they did that, the professor that I was the TA for instructed us when we graded the lab reports that for every time that they put NA like this, for that, we would take a point off. Lab report was worth 100 points. I had kids that I literally had to give 30s and 20s to. Because the professor was that big of a jerk.
No, I get it, because that completely changes the meaning of it, though.
It does, but I think it was a little excessive. I mean, the first time the kids ever really seen the abbreviation.
No, wait, talk to William Alderman.
Now, here comes the fun one. Mole to volume. For this, I have a special box. I give you my special box. I think it's in here. It is. Very special box.
It is pretty special box.
very special because what's inside the box?
This is Shredder's cat.
No, but we will discuss that in this class. So just like before, we can go from moles to volumes.
Maybe take my calculator. Yeah.
Wait, no, I wasn't talking about the calculator. Never mind.
Up here and look at it like
And you
my
can
phone.
go from volume to mole. To do this, you need a conversion factor. The conversion factor, I'm going from mole to volume, so 1 mole on the bottom. And the unit that we use is liters. And there's a very special number that's associated with this. I'm going to introduce you to my special box. It has 2 purposes. Purpose number 1, sometimes I set it in the floor and I leave my backpack sitting on it, but now I'm using that stool. So really has no other purpose. Besides that, this is the only purpose I have for this box. Whoever purchased this really wanted to waste tax dollars. So I'm trying to get every bang for the buck I can. Every class gets to see it now. There is 22.4 liters of gas inside this box. Yes, I know what you're thinking. Yes, this is the only use I have for this box. Literally. There's no openings. It's just a box of trapped air.
Awesome.
So, if you're showing this to your parents, you better stress that I'm not the person that went and ordered that. I didn't waste your tax dollars on that.
How much was that?
I don't know.
$1 million.
Who cares if it was $3? Are you enlightened anymore that I showed you a box?
Yes, it's pretty funny.
I like that box and stuff off.
Extremely.
Because I made the joke, it'll stick in your mind. That's the whole point. I made the joke, 22.4 liters, sticks in your mind. So, till next year, buddy.
That's tough.
If there is next year. Never know, y'all may not trash me so much that I have no chemistry next year. I hope not. So you get the reciprocal. Let's say I'm going from volume to mole. I'll have 1 mole on the top. On the bottom, I have 22.4 liters. So some important information to remember when it comes to volume. The special number, 22.4 liters per mole. There's only one time this can be used though. I have to decide. How many of y'all are going to sign up for AP Chem?
No, life is crazy.
Raise your hands or else it lasts. Tanner's gonna do it with you, trust us. Group 0 sticks together.
Hush up. Tanner ain't even here today. Group 0 is like had half attendance in my class.
What are you talking about?
Tough.
Here's the important thing to keep in mind. Can only do when at STP. STP stands for standard temperature and pressure. That's what you're going to look at here. I will openly look at you and tell you. How do you know if you're at standard temperature and pressure? For right now, this is the basis I'm going to build it off of. I'm going to do for you guys what I've done in years past for my normal chemistry classes. We go to AP Chemistry next year. I will actually tell you what standard temperature and standard pressure is, so that you'll have it to memory, because you'll actually be using that information. If I tell you it's at STP, you're good. Do the calculation. If Mr. Hall gives you units for standard and units for pressure, not standard temperature pressure. Dead giveaway, cannot do the calculation. Okay? Golden giveaway. Time we got? Two. Do you have any questions? I know you're probably full of questions, but you don't know what to ask. Here's the big takeaway, is these numbers. Avogadro's number, the 22.4 liters, you have to keep those to memory. I will not allow you to use the MOMAP on your quiz. Just letting you know. Okay? So please make sure that you are using them and getting them to memory. There's a lot of things you should have to your memory right now. Is one are the prefixes and their values that I gave you guys. Second is how to calculate average atomic mass. Third is I need you to have these numbers to memory. And fourth is all the information we got on the 3 subatomic particles. Your MOMAP, I gave this to you for you to write down and do, because now what's going to happen is I will erase this and I will no longer have it. You do not have to use this. But if this helps you visually, use this. I've had kids that literally took the first 3 minutes on their quiz as soon as I gave them a periodic table, flipped the periodic table over, and they drew out the MOMAP. That's fine. Do what you need to do. That helps you be successful. So feel free to use this. Don't feel bad if you need to. Besides that, any questions? Then tomorrow, when we come in here, I will have Prof. Bob waiting for you.
That's
You
like
gotta get this.
There's a difference.
That's a verb.
Yeah, I'm a
Guys,
bit
I'm trying to
confused. I
say
don't really
things
know
like
what's going
chemistry
on.
class.
So when you are looking problems like this is the most important part you have to get. First thing you need to do, develop a plan. Before you do anything, develop a plan. The reason I tell you to develop a plan, I have learned from years. No. I've learned from years and years of teaching this. You are not used to as many steps and as long as a process as this is going to be. Develop a plan. If you want to use your MOMAP, use the MOMAP. But first thing you have to do, find where you're starting. Well, how do you know where you're starting? Well, what number do I give you?
78.6 kilograms.
So 78.6 kilograms. Here's the big part. Kilogram is a unit of what?
Measurement.
Mass.
Mass.
So true.
So I start at mass. How do I know that? Because I start with kilograms.
So true.
Now, we have to find the stopping point. In order to find the stopping point, it's all about what am I asking you. If you remember, yesterday I told you those 4 units in the end, don't freak out about it. Do you know whether you should put atoms, molecules, particles, or formula units? Yeah. How many molecules? This is my stopping point. So what I'm trying to do, I'm trying to go from mass to molecules. Here's the way to look at this though. Can I just go straight from Oceana city limits straight into Beckley? No. You You got different ways you can go. You have to go through somewhere else. You can't go straight from mass to molecules. What are these called again? Mole conversions, so we have to use the mole must show up somewhere in the problem. You either start with it, end with it, or you will use it. I promise you. Moles will show up somewhere in the problem. So you cannot go straight from mass to molecules. We have to first go from mass to moles, then from moles to molecules. Okay? We have a plan. It's a very basic plan, but this plan is key to your success. First thing we're going to start with is the mass. What you need to do, you need to take the number that you're given and set it over 1. 78.6 kilograms. Now, I go unit crazy. Units are my friends. I love them and I use them very well. Do you have to write all the units out that I am? No, you don't have to. If you stop right there, that's fine. But me, I'm also going to look and say of calcium hydroxide. I set it over 1. This is my starting point. Now, when I look, I start at mass. On your mole map, I made a statement. When you are going to, from, or dealing with mass, you have to use the periodic table. We're going to have to use the periodic table in this case. But the reason we have to use periodic table in this case is we have to come up with the conversion. There's one of two ways you can do this. One is using the mole map. 2 is just by reasoning it out. Where am I starting? I start at mass. Where am I wanting to go? I want to go to moles. To get to moles, I want to get there means the mole has to go on the top. Where I'm leaving goes on the bottom. Bless you. I'm leaving mass, which means there has to be grams on the bottom. Why did I put grams and not kilograms?
Because it has to be a base unit to do the conversion.
That's the base unit. Everything that comes off the periodic table is in grams per mole. That's why this is a problem. There's so much work right here in the beginning. I have laid a trap for you. Hopefully you caught the trap. There is a problem here. Do you see said problem? Someone tell me what is the problem? It's in the kilograms. Grams will not cancel out kilograms. Which means you have to do a metric conversion.
It all comes full circle.
Yes, it does. Everything in this class will connect back together. I promise you that, okay? You're going to feel like I've lost my mind until about February. And then in February, you're going to be like, oh my gosh, dude, this is so bad. We can't do this as this is. We have to convert that unit. Now, we can do that. Well, how are we going to do that, Mr. Hall? Very simple. We're going to use the steps that I taught you. We're going to do the Mr. Hall method, okay? So we got 78.6 kilograms is equal to, the unit I'm trying to go to is grams. Step 1, what is it? Write the number down. Times 10 to something or other, right? Now what do I do?
Look at that handy dandy sheet we got.
Find the prefixes. Find the what in the prefixes.
Exponential value.
What?
Exponential value.
exponential values, but we're gonna find the difference.
Sorry, I
Yeah.
thought we were going a little slower than that, my
No,
bad.
you're okay. What's the same?
Stop laughing.
Grams are the same.
Get dragging.
So the prefix here is kilo. What's the exponential value for kilo?
3.
3. Minus, is there a prefix here? No. It's the base unit. So what's the exponential value?
0. I had to put my thinking cap on.
3 minus 0 is 3. Is there an exponent on the units? So I don't need to multiply. Is there an exponential value I start with? No, so I don't need to add. It's just 3. Now this changes up here for my problem.
This is awesome. Amazing.
Would I still get it right if I do not write it in scientific notation? Like I put 78,600?
Yeah, you're fine.
Okay.
I'm not that person. Okay, I'm gonna be honest with you, and this is probably a little bit too honest. It's probably especially not good because I got a camera in my face. But I'm gonna be blunt and honest with you.
You want me to distract?
I had a professor in college that I really liked him because on day one he taught us something. His whole class he gave us a problem, we solved it, and he was my Calc 2 professor, and then all we did that day was we kept changing the numbers. And we made it mathematically correct every time we changed it. And he looked at us at the end of the day with the last 2 minutes, he said, now which one of these answers is correct? And we're like, well, isn't technically all of them? So how do you want it? He said, I don't care. I have a doctorate in math. I teach math. Give me a right answer. And we thought, holy smokes. And I will be honest with you, I am fine with that. Because that's like, if the correct answer is 1/2 and somebody puts 0.5, who's correct?
I've got an answer wrong before like that.
And that's my thing that drives me nuts. They're both right. Doesn't matter.
Blame Alex.
See, that drives me nuts. I can't stand that. I do not care. So if you did 78,600, that's fine, Eli.
Blame Alex.
Calculator ain't gonna care. I ain't gonna care.
I imagine that would get really complicated whenever you get big exponents. So.
It is. At that point, he'll throw it in the calculator. How to do it.
Miss.
Now, this is set right. I want to draw your attention to it, though. I have to admit something to you, okay? Mr. Hall loves you.
What?
Mr. Hall also very tricky, okay? Mr. Hall is convinced that he prepares his students well enough that they can compete with anybody, okay? You know? So, Mr. Hall likes questions within questions. So things that you have to catch and corrections you have to make.
It's like fishing.
So that was one thing, which is
It's like fishing.
interesting. You have to catch these things.
You know?
I will do this throughout this class. Just a heads up to you.
Why?
Now, we need to find the number that goes here. In order to find that number, you have to look at what you're dealing with. I'm dealing with a compound. Does it matter if you know you're dealing with a compound right now? No, I could care less. But this is a compound. In order to do this, I have to be able to find what is called the molecular mass. This goes by different names. I use molecular mass because the majority of you are probably going to end up going somewhere into organic chemistry, which deals with molecules. Or you're going to bio stuff, that's going to deal with molecules. They're going to be focused on the molecular mass. That's the terminology I choose of it. The molecular mass is the mass of a compound or molecule. Here's the key. To find it, use the periodic table. We'll use the periodic table. Now this is how you're going to do this. If we're going to find the molecular mass, you have steps to it. So I'll give you the steps here. Step 1, we will write down the elements in the compound / molecule. Step 2, out from that, write how many of each element is in the compound / molecule. Step 3, multiply that by their average atomic mass from periodic table. Step 4, add together.
I don't think you said anything about it, but we don't have to memorize the periodic table, do we?
No, Lord, no. I give you a periodic table on every quiz you take except for 2, the element quiz and the polyatomic quiz.
I was just talking to Eli, I was like, I just realized we're gonna have to memorize this whole sheet, the whole periodic table in order to be able to do
I remember
these.
in
No.
8th grade, I had like a very small, like basic chem class, and she said, yeah, I'm not gonna make you memorize the periodic table, but in high school, they're gonna make you know everything. I almost cried.
It's dumb to do that because now I do make you memorize like 50 elements
Yeah.
because I just need you to know where they are and get used to them. To memorize that whole thing is dumb. Like I don't have it all in memory. I have a good deal of it. Fascinates kids. They sit there and they throw out numbers and I can tell them the elements. I will tell you this as you're writing that down because I know you guys won't get the steps down. On every quiz, I give you the periodic table first, and the reason I do it is for a strategy on test taking that I like to encourage called dumping. And dumping is when you have a bunch of information you have to memorize, like Avogadro's number, like the volumetric constant for a gas,
24 something.
22.4 liters. If you want to use the MOLMAT, you got that to memory. I give you the periodic table, you literally flip it over and you dump. You dump all that information on there. And then I come through with the quiz. You have your little cheat sheet. But you just made it, so you're not cheating. So this is what this is going to look like for you whenever we're doing this. I have to look at the molecule. So I have calcium hydroxide. I use calcium hydroxide on purpose because I want you to see how to read out molecules. And I'm going to do this again with another one. You have to write out every element that's present. Now there's a key indicator when it comes to the chemical symbols of an element. First letter is always capitalized. Second letter is always lowercase. Perfect example is chlorine. Chlorine is Cl. Everybody, why not use chlorine? Because everybody messes this up and wants to say that's Ci. Second letter is always lowercase. So if it was Ci, it would be that. And that is not what that is. It doesn't even exist. First letter is always capitalized. Second letter is always lowercase. You use this information whenever we're reading out compounds and molecules. So I have big letter, little letter, that's one element. That is calcium. And here's how I like to do it. I list all my elements out. Next I have oxygen. Next is hydrogen. And I list those out like that. And I put a colon next to them. Now what I do is I write down however many those appear in the problem, in the compound and molecule. So you look at calcium, there's no number there, so it's like math class. If there's no number in front of X, what's understood to be there?
1.
A 1. So we have 1 calcium. Now here's a difference. Inside the parentheses, there's a 1 with oxygen and a 1 with hydrogen. But outside the parentheses, there's a 2, which means there is 2 of these hydroxides. It's a polyatomic column. You don't need to know that until like December. But oxygen and hydrogen, we take the little number on the outside and multiply by the big number, the little numbers on the inside. So it's 2 times 1, which will give me 2. And 2 times 1 gives me 2.
Mr. Hall, what if there was a 4 there?
You would go 4 times 2. Is 8. Promise you will practice it. Then from there, you now go to your periodic table.
4 where?
Where you
If there was a 4 there,
Where would the 4 be at?
it would be like here.
Oh, okay.
Uh,
I thought you meant in place of the 2. I was like, if the 4's in place of the 2, isn't it
No.
just 4?
so true.
Okay, now you go to your periodic table. You look on your periodic table. So I look at calcium. Calcium's right here, atomic number 20, and I read off the average atomic mass. I multiply that 1 by the average atomic mass, so 40.08 grams per mole. Then oxygen, I look at oxygen, it's atomic number 8. So it's over in the 16th column. That is 16.00 grams per mole. Then hydrogen is number 1. He was number 1. No, nobody.
No idea what you're talking about.
SpongeBob.
What is it? What?
Kick him
I've
out.
watched SpongeBob my whole life. I don't
Get
know
out
what
of
you're
class.
talking. What is that from?
You should come to class on time.
He's talking about stupid yard sale and it's like race car dude's hat. I don't know.
What?
Smitty Man Jenkins.
Bro, and he sells it and he really misses it. And they like accidentally kill it.
But
and get
Mr.
it back.
Krabs, he was number 1. It was his hat, Mr. Krabs.
Oh wait, the one where it's like that.
No, it's too late. It's
That
too
episode
late.
creeps me out. I remember that. I was terrified of that
The
episode.
cop's car. And he's just like,
Average atomic mass of hydrogen is 1.01 grams per mole. Now what I've done, step 2 was me writing down those first numbers. Step 3 was multiplying by their average atomic mass. So then you do this at 40.08 grams per mole. You get 32.00 grams per mole. And we'll get 2.02 grams per mole. And then I'm going to throw that all in the calculator.
G-moles.
Which gives me 74.1 grams per mole. before I do anything with the number, does everybody see where I came up with these numbers from? Does anybody have a question of where I pulled those numbers from, the red numbers from?
No, but I do have a question. What does NA mean?
That
Like
guy's
in
Oh,
this,
yeah, which one, are you talking lowercase a or capital A?
capital A,
That's Avogadro's number. We're not there yet.
okay.
Okay,
Okay.
Oh, yeah.
so everybody sees where I got this from. Okay, because you're gonna be expected to calculate molecular masses of things.
Yes, you did. Is that what it is?
So now I have this number. That is the molecular mass of calcium hydroxide.
Wow.
That number goes up here.
Not for me.
So 74.1 grams of calcium hydroxide. Here's the beautiful thing of that. Grams of calcium hydroxide cancel, grams of calcium hydroxide cancel. What unit am I left with?
Big.
I'm left with mole. Guess where you are now?
We're at mole. Wowee. We made it, guys.
Wow! Wow.
Here's where I'm going to look at you and tell you that was a lot. That's where all the hard stuff's at.
No, no biggie.
From here, it becomes easy now. You have an option, okay, going from moles to molecules. You can type that into a calculator, get out an answer, and you'll have the moles of calcium hydroxide. So that you can use that, or you can set up the third conversion factor. Where I don't need the same number of moles for two problems, I'm going to set up another conversion factor. Okay? Everybody all right with that?
Mr. Hall.
Yes.
Why did the 78.6 times 10 to the third over 1 go away?
It didn't. The number's still there. The unit went away. See, this is why I don't like the fact that teachers don't push units until you get to me, because you are now looking and saying, but that went away. No, it didn't. The number's still there. The unit went away. That's why I marked through the unit, not the number.
Okay, so now, is that 74.1 moles we have?
No, that is 1 mole calcium hydroxide over 74.1, because this is also what you're going to do. You start with this number up top in the numerator. Since this is in the denominator, this number gets divided by that. And the beautiful thing is you don't have to worry about multiplying by 1. This is why I always have you write over 1 so that kids can visually see things.
Oh, okay, never mind, that makes sense. I was just dumb. I realized that you just move it over.
You're good. Okay. So, now we gotta get some molecules. So you use MoMap, you want, and you can look on it and see, I'm going from moles to molecules, what's the conversion factor look like? Or you can reason it out. I'm gonna do it from the MoMap. I don't have one, I'm doing it in my mind, so you look at yours. I go from moles to molecules. So I'll follow the arrow that goes from moles to molecules. Whenever I do that, I have Avogadro's number and molecules on the top. So I have molecules of calcium hydroxide. This really should be formula units. I messed that up. Doesn't matter. I told you molecules, we're doing molecules. But for video purpose, it should be formula units because it's a compound. And then on the bottom I have mole of calcium hydroxide. That'll be 1. Now, here's the important part. Here's where it gets easy. Super simple, super easy. I'm going to molecules. What number is going to go with molecules? Avogadro's number.
Yeah.
What number?
The avocado number.
6.022 times 10 to the 23rd molecules. Now, moles cancel out. What am I left with? Unit-wise,
That
Molecules.
number.
what am I trying to get to?
Molecules.
I've hit the end destination. Now it's just punching in a calculator. So I'm gonna punch this in a calculator. Here in a second, I'm gonna show you something very important, by the way, because you don't know how to punch scientific notation in a calculator. So I take 78.6 to the third power, well, times 10 to the third power, sorry. Divide that by 74.1. Then I will multiply by 6.022 times 10 to the 23rd power, and I get an answer. Don't want to write it in red. I don't want you guys to get confused. So when I get this answer, I get 6.3877 times 10 to the 26th power. And that is molecules of calcium hydroxide. Understand something. I only went 4 places past the decimal. 4 places is plenty. For whatever reason, I randomly chose that one year, and that's what I'm stuck with.
So what did you multiply to get that?
All of them.
I'm gonna show you. Because it is very important.
How many numbers, how many digits do we have to go down, like, multiplicate, like, what do we round to?
What do you mean we go down to?
Well, I got 638,7708.502, and you just put 6.3877.
Do you not have a scientific notation number?
No, I don't know how to do that, I just did the old fashioned way.
Yeah, you should still come out with an E. You guys are gonna love me today.
Oh, wait, you're right, I
He's
did
doing how
something
he
wrong.
did it back in the day.
Oh, because I didn't
Did you
put
just
times.
call me old?
No, I'm talking about Dale.
Oh.
He did it back in the old
I
days.
was like,
Oh,
Kenzie
Dale.
Mouse.
He said he did it the old fashioned way, that made me giggle.
This is quite
That's what we
humorous.
think.
Man, a guy really shouldn't leave stuff there. Okay, I want to show you something on your calculator. Now, this is very important that you get this.
Oh, wait.
Hopefully, we can get the camera to get this.
Hello, camera.
Okay. I'm gonna turn the lights off just so it shows up good on the camera. Okay, maybe not good.
This is awesome.
Maybe not.
That's why I was like, it's good.
This is
I don't
the
know.
best dad.
Wait till it turns
Wow.
green.
I love this equation.
Oh,
Really?
Whoa.
okay,
How did you know I was gonna do
I
that?
can work with this.
Wizard.
okay. Here's the thing, why does mine look like that? You guys are probably used to typing out, you probably did 78.6 times 10, and then you did a little arrow key, and then you typed out the exponent. That's actually the wrong way to do this. Calculator's actually built to do this for you. So I'm gonna teach you how to do this. This is how you do scientific notation in a calculator, okay? So the first part is type the number down. Now I like using parentheses, so I'll do parentheses 78.6. If you don't know how to type that in the calculator, you shouldn't be in this class. Then from there,
It's hard.
on the calculator, here's what you're gonna be looking at. The little blue second function key up here, you're gonna hit it. You get the little arrow inside of the blinking black box that lets you know you're in the second function. You see the number 7? Go above it where that comma is, where you see those 2 E's in the blue, hit it. You see the E there now? That E takes place of times 10. So now it's reading scientific notation. That is reading 78.6 times 10. Whatever number I type in next, it knows that's the exponent. So for me, it's a 3. Close off my parentheses. Then I divide by 74.1. I do parentheses just because I like to. Then I multiply. We're going to type this one in again. We got to type in scientific notation. 6.
To see the homecoming court girls in her class turn at this time.
6.022.
This is so
How do we
crazy
do
stuff.
the scientific notation again?
Second function and then press funny comma button.
Why is there a comma on a calculator? This isn't English, this is.
See if I can get the focus in. So second function. It's come right here on this little comma, right there where the double E's are.
I think we should make our
Hit
own
that.
calculator.
Whoever's watching this video is like, oh my gosh, you're killing me, man. Then I type in the exponent. You don't need to type a multiplication. You do not need to type the number 10. The E takes place of the times 10. Type it in the parentheses, hit enter. Now, that tells me that the answer is 6.387708502 times 10 to the 26th power. Should you write it on your paper as 6.3877E26? No. E is for calculator. Answers on paper are times 10. And then you put that as an exponent. Everybody got it?
Why are you rounding to the 7-7?
I just go 4 places past the decimal. The truth of it is I'm supposed to teach you called something sig digs or significant figures. I don't know what they call them anymore. I guess I'm actually going to have to teach y'all that because the hope is that this class will get me an AP chemistry class. Hey,
I was gonna say.
I know this was a lot today. Watch your eyes. I know this was a little, this problem was hard. Do not walk out of here being stressed or overwhelmed by this. If you have questions, feel free to come see me. Tomorrow, we will have another Prob Bob, and then we're going to break this thing down and make it more simplistic and easy. Please come to class, and come to class on time.
Listen, Mr. All, I'm here before you start.
Instead of like normal, like your syllable, it has the prongs. What?
As a seasoning.
It's dry pineapple, it's different than pineapple. It's, try it.
No,
Try
I'm
it.
allergic.
Oh, that makes sense. I just said that. What's a pineapple?
Why does it look like that?
It's because it's dried. It's really good.
Okay, what I've given you on your entry slip, there is a mistake, and the mistake is made on purpose for you. Because I want you to catch it and to get it and understand it. How important.
One quick addition, sophomore donut money is due to homeroom teachers tomorrow. And we have a shout out from our counselors to Mr. Hall and Mr. Short.
Congratulations.
Yes, my teacher! Yeah!
I have no idea what the shout out was even for, and we'll have no clue.
They're celebrating.
Pistol! They tried to one-up us. Who do they think they are? I don't know who's in here.
Is he in the room beside of us?
No, he's.
All the way down.
Listen, if Mr. Short was in the room next to us, we'd get in trouble. Okay? I'm just gonna say it. Okay. Alright, anyway, there is a mistake on the entry slip. I did it to you on purpose because I want you to see something from my point of view. Zoe said it beautifully. She looked and was like, is this mass? No? Well, what is it? There's nothing here. I'm like, exactly. There is a problem. Yeah, you can give her. There is a problem. Look at the number I give you in that. Try and calculate how many moles are in a sample of 5.45 times 10 to the 24th of carbon.
No.
Of what of carbon? I want you to see this from my point of view. This is what it's like whenever you give me an answer and don't put a unit with it. Is it nice? No. Don't do it. So, we got 5.45 times 10 to the 24 atoms of carbon. So, we are starting with, hey, by the way, I want to take this time as I get a calculator to remind you, if you have not signed up on Remind, I need you to sign up on Remind. It is super duper important that you do this.
What's your code, Mr. Hall?
I done gave it to you. I ain't getting it again. You have to learn how to be responsible and to do things. Yes, sir. You're very welcome. So it's in a live grades message. I wrote it on the board that day. Sign up on it because I'm sending video links through there and I'm going to start holding back. I'm just going to start unleashing. 5.45 times 10 to the 24th atoms of carbon. Now, this is the starting point. Make a plan. Where am I starting?
There.
Which is?
Adam.
Atoms. Where am I going? Moles. So, can I go straight from atoms to moles? Yes. I can go straight from atoms to moles. I set this over 1. I set up my conversion factor. Where am I going? To moles. So what goes in the top?
1 mole.
1 mole. What goes in the bottom?
We need the periodic table.
You do not need the periodic table.
Avogadro.
When do we need the periodic table?
Is it for mass?
Only for mass.
Yeah, I got a little ahead of myself.
You need my good friend. You need his special number. Avogadro's number.
24.6 liters.
24.6 meters.
No, that's not even the right factor for volume.
Oopsie.
Avogadro's number 6.022 times 10
That was the wrong number.
23rd. What unit goes down here?
The grams.
Where are you leaving?
Mole.
Atoms.
That's what goes on the bottom.
Yeah.
Hey, Mr. Hall, that exponent looks a little weird.
Make it right on yours.
Thank you, Mr. Hall.
Atoms of carbon cancel out, leaves me with moles of carbon. Do I need to do anything else?
Sure.
Where am I trying to go?
We're done now, right? We're just trying to go to mole, right?
This is Zegers.
Is that the end? What's the plan?
Oh, I mean, we gotta finish multi, you gotta get out.
Yeah, I get that, but is there need of another conversion factor or am I done?
Done.
Where am I trying to go?
Mole.
Where am I at now?
Mole.
Do I need to go any farther?
No.
No. If I need to go to Beckley, I do not need to go through Beckley to Fayetteville and then turn around and go back to Beckley.
It's
Okay?
gonna be triple Sherman.
It's about the journey, not the destination.
You're about to be on a journey. Alright, so punch this in the calculator. Hopefully you got your calculator. And hopefully you remember how to punch this properly in the calculator.
How did the computer not go? I got the strongest computer in the hand. Everything unplugged. The computer just stayed.
Absolutely everything else. Oh yeah, I remember that. So we just enter it like,
Hey, I want you to give it a shot. I want you to type it in, see what you get.
and the
Please type it in properly.
the E replaces the 10.
The times
right?
10.
Okay.
get one thing, does it start with a 9? Does it start with a 9 or any of that? I had it calculated for you,
No, I had a calculator
now
with
it's
me.
thinner.
How do you do it?
Oh,
Did you know God? Did you have brain damage?
Hey, hey,
Dude, chill out.
Second.
Relax.
relax.
Takes place 60 times 10.
He's Louise.
Now you type the exponent.
Relax.
Don't say a word.
You're
Don't
okay.
call me bald.
Don't call me man.
He's not, he's clearly not a man.
Hey, he's like, can I see
Don't
your
call me
answer?
bald, I'm a man, actually, I'd rather be called bald man.
9.05.
Don't call me, I'm not a girl.
Where's the 64?
5.45.
That's a really good question, actually.
And all that.
Over 6.
I don't think I did that. Am I supposed to look?
022.
Oh, wait, I multiplied.
You're right.
Uh-huh.
So second.
So,
Comma. Why does it mean
I multiplied.
Yeah, see, I did too.
because 5.45
That's so
it'd be on
true.
top.
Now where you
Yeah.
didn't put in parentheses, I would hit enter. So it would,
Math.
now divide.
I don't like this math.
Then, yep, there you go.
Wah,
Did you just say womp?
wah, wah.
You know what I'm gonna do? I'm gonna stomp on you, because you're this tall. Well, that's what you're.
Hey,
Hey,
let's
divide
continue
just by
this
other
conversation. Yeah.
You got 9.05.
Whoa.
Oh, yeah.
How many Kinseys
You do
could
the
you
E.
take in a fight?
I could take every Kinsey.
No, be real though.
Okay, be real.
Being so real.
How many Kinseys
He
could you
takes
take
us
in
to
a
the
fight?
top. There's a reason.
I'll be like 50.
You think 50?
You know,
why 50? Because I just gotta pick up one Kinsey and just start.
I weigh
bang,
120,
bang.
by the way.
Huh?
What is the realistic factor of you picking a 120-pound girl up and swinging her around?
If I can spin fast enough.
We can do this, we can do
Would it
it.
not?
I said,
I can actually bench 5,000 pounds.
Okay, you know,
you're only 120 pounds.
I'm still a grown person.
You're
with
5'2".
With the capability of fighting back. I'm
You
not
know
completely
karate, right?
defensive.
You could
Yes.
you could probably punch Taylor for 20 minutes straight and give him one move.
She's not that weak.
I'm not an infantile baby.
You can't reach his head.
Alright, here we go.
His head.
I'm wearing
dead.
jeans.
I'm dead.
I had them removed for fighting,
I said,
kick
I
babies.
said your seat at first.
Caitlin is completely confident he could
He's-
take 32 of them.
He's wrong.
Caitlin Lester said he probably couldn't take
Oh, that's
184.
I could take,
23 on that first.
okay. I'm gonna
So
be
you
as
choose-
real as
however you
possible,
wanna do
okay?
that. Hit second.
A lot of you can overwhelm me, like jump on me and start like beating me up.
Exactly.
That happens,
It's gonna be like
but,
that one game where you
but,
smash
like-
them all. You just
I don't know, it depends, I'd have to fight you first and then I'd see, cause I don't know how, what fighting is.
Yeah, we
So at lunch,
Hey, so the ones I looked at, you guys are looking good, like you can punch it in a calculator and get it right. Now, there's multiple ways to punch this in a calculator, okay? There is. Some of you guys want to use the fraction keys, that's fine, just be careful and make sure and trust parentheses, use parentheses as your friend. You should get,
holy
oh,
crap,
we only have to
noodle
go forward
macaroni.
past,
Cannoli.
I ate cannoli yesterday.
I don't have to write out
It was
that
pretty
pretty
good.
good, obviously, but.
cannolis are so good. 9.0501 moles of carbon for the English people.
So you only have to go
Four places.
past the decimal?
Yeah.
Do you
Okay.
still round if you can?
Now, well, since you brought that up, I want to address it. If you should round up, if you don't, I'm not going to count it against you. I'm not going to kill your grade because of rounding rules. That's
You're
stupid.
done, you're on what?
I love
But would you prefer us to
I thought you said kill my grade, well,
He's not gonna kill you.
Yeah, but if you don't, I mean,
it says stars
Okay.
on it.
That's
Is
okay.
there
I'm gonna look in your house, okay?
anybody in here that
Stars.
didn't get this number? If you didn't get this number, it's probably because you're punching something in the calculator wrong.
Stars.
What the world would we do?
Thank you, it was like
There you go.
6 bucks.
to know.
And it's like, wait, really big.
But how many kisses could you take on with brass knuckles?
With brass knuckles, I'd take
I'm
on
doing
that.
like 100
Oh,
bucks.
you use
One
all these.
punch.
You think,
Yes.
why do you guys think have
What
like,
E did you
Brass
get?
knuckles.
Brass
Yeah.
knuckles are.
I know, but like,
Of either.
y'all act like I'm made of glass.
With brass
You
knuckles,
think
you basically
you
are.
Anybody.
Wow.
In
And you
general,
don't
y'all
need
are
to do
like,
that X
You could
I
probably
could take
take.
50,
Because
you
it's
could
gonna
take
be
I
sections.
couldn't
Should
take
have
50.
parentheses.
You could probably take like 3 panties if you had brass knuckles. That's how, that's
Yeah,
how strong.
brass
No,
knuckles.
I mean.
Yes, you could. You could give me a concussion.
Brass knuckles go harder.
I hurt my
One
stomach.
punch.
We
It
should
Hey.
doesn't matter.
I love y'all. That camera's recording the whole conversation.
Camera, what do you think? How many Kinseys could you take on?
How many Kinseys can you take on with brass
Here's
knuckles?
the important part. I divided. because
Kinsey knows karate, I couldn't beat her even if I wanted to.
It'd be like that.
Hey, anybody else having an issue? I wanna make sure you're using the right Eve. I wanna make sure you're punching it in. Yeah, what's up?
I'm
How do
dead,
you
bro.
know whether to divide or multiply the?
I love that question. It's a great question. Hey, listen up. We got a great question up here. How do we know whether to multiply or divide? I have a trick.
It's a secret.
You'll see for me, I always start your numbers over 1. Always. If it's in the numerator, you multiply. If it's in the denominator, what's the denominator start with? A D? What's divide start with? A D. If it's in the denominator, we divide. Okay? Does that help?
A little bit.
Okay. Mr. Hall made a promise to you yesterday. I gave you one prob bob. That prob bob was hard, right?
For sure.
Difficult. You probably walked out here saying, "I'll never be able to do that." I had freshmen that came in and seen that problem on the board, and they went, "I'll never be able to keep up with that." Like, yeah, you will.
It looks more.
So I explained to him, I showed you prob bob. Why? Because I want you to see how hard it's going to get. But the important aspect of it is I start you off. The second reason I gave you this entry slip. This is an easy one. Did you need the periodic table? How do you know you didn't need the periodic table?
Use this.
Doesn't do anything with mass. Now, if it deals with mass, if you're leaving mass or ending at mass, you have to have the periodic table. In this case, you do not. So, you don't gotta worry about it. This is an easy one. And this, after I give you this next prob bob, we go easy. And I'll kick them up. Okay?
That's what I'm talking about.
I was such a sincere guy.
Hey, Emily. Do I have a future?
All right. Now, I want to tell you,
Oh, wow.
this prob bob is a very nice prob bob.
Uh-oh.
Okay? Very good.
This one better not have all kinds of weird units just to or I might cry.
He might.
You are given a sample of
Make these numbers, like, you pick them off the top of your head.
yes, absolutely. This problem's actually coming out the top of my head.
You were very smart for being able to think of a number that high, Mr. Ross. I couldn't do that.
I
That is a
can't
lot of.
Very
digits,
dangerous,
Mr.
actually.
I can't get past 3 of them.
I bet if
If
you
I
think
tried
too
like
hard, it
steam
might
would
come.
Hey,
start coming out of my ears. and
How hard do you want this prob bob?
I wouldn't-
The
Max it out.
hardest it can be.
I
Max
want
it
to
out.
pooping myself. I want to
No.
cry. I want to never come back.
I
Okay,
wanna see my capabilities.
There is something
No
I'm
lie.
going to add to this that I openly will tell you is a trick. And I will show you the trick of tricks that I will hold on to and pull out every chance I get.
I want
You are given a 7,864.3 cubic centimeter sample of
Don't do it, Mr. Hall. Don't do it. I know what you're doing.
nitrogen
He
gas.
knew it.
Ugh.
He knew it, Mr. Hall.
Calculate
You've gone too far.
I can't believe it, Mr. Hall.
how many atoms are in that sample as well as the mass of the sample.
Uh-oh.
I changed my mind on
I want you to keep that problem up there, Mr. Hall, so that all through the classes know how
Give it.
important it is.
Given that, you are in a room with 1.73 atmospheres
Okay.
and set to
Is that supposed to be Adam?
25 degrees Celsius.
Uh,
I'll give you a second, get it broke down.
yes.
A lot of information here.
We're gonna go with all of the above.
It's gotta be at least one.
Welcome to chemistry, where multiple choice does not ever live.
Mr. Dawson, Oliver has to do multiple choice.
So, the full question here, you are giving a 7,864.3 cubic centimeter sample of nitrogen gas. Calculate how many atoms are in that sample, as well as the mass of the sample, given that you are in a room with 1.73 atmospheres and set to 25 degrees Celsius.
Mr. Hall, how do I have 7,000 centimeters of nitrogen gas? I don't understand.
Cubic centimeters is a volume.
Uh,
You know
Okay.
where we're starting.
Hey, first off, this is a problem, Bob, like no other. Right now, there's gonna come a time in this class, I'll give you a problem like this, and you all are gonna work your fingers to death, and I will probably sit on the desk over here, waiting my time for someone to look at me and say something. Here's the answer.
You're gonna give me the answer.
I'm gonna give you the answer that fast.
Wow.
I didn't have to do nothing.
Good thing I worked it all out.
I actually did solve that in my head, but I can't tell you the answer.
You won't believe him.
The government is watching us, and if we tell the answer, they will strike.
I can't let you know how smart I am, Mr. Hall.
Hey, we knew that.
On your mole map that you did, I told you if you're gonna do something with volume, it's a very important thing, very key. You can only solve it when what?
It's
It
not
went
a,
up to STP.
When it's at STP, which stands for standard temperature and pressure. In this case, I told you in my class, if I give you values for pressure or temperature,
it's not.
it's not at STP, that you are not to solve it. Those right there are the dead giveaways.
The ATM.
I knew it was baloney.
What's ATM?
Good job.
Atmospheres.
You know what, I'm lowering the amount of Kinseys that could beat me by one, because that was, because you answered that, you know what, that
Now,
shows smarts, so.
let's take this problem and do this.
How am I supposed to?
Why would you do that, Mr. Hall?
Now I gotta go back and erase everything.
Now I gotta like redo that problem in my
You
head.
can just add a note to the bottom of it.
Well, stop it.
That is at STP.
If you don't include that it's at STP, can we assume it is at STP? Is that okay to assume?
Ask me, okay? Because there was one year that I forgot to put it on the quiz like that, and luckily a kid asked me, and I'm like, absolutely that's at standard temperature and pressure. Sometimes I get a little excited about the question. Like right here, this is a really good question. So when you look at this problem, we gotta develop a plan. You gotta have a plan. Must have a plan.
That's what I'm talking about.
Where am I starting at? Look at the number and look at our units. What is that a unit for?
Milliliter.
Volume.
It's a unit for volume.
I knew that.
So we're starting at volume. So volume's our starting point. Where are we wanting to go?
Mole.
Well, we
I'll
have-
play, I will,
we need to figure out how many atoms
We're
and
at,
the mass.
we're at volume.
We need atoms and mass.
So we're gonna
But
have
can you go straight from volumes to atoms?
No.
No, you first have to go where?
Mole.
Which is where I'm very proud on those of you that said moles, because I think you were thinking, it's a mole conversion, we have to go to moles. So we're gonna go from volume
It's the intersection, Mr. Hall.
to mole. Now, here's the fun part. At moles, it branches. I'm gonna have to branch to go to atoms, but I also have to branch to go to mass. So you're gonna see the road divide. So we will go to atoms and mass. Mr. Hall, what does that mean? You will have two answers here.
Yeah.
You have to have both of them.
I got both of them, Mr. Hall.
Can I be honest with you? I know it seems very elementary level for you to write a plan down, but I think it's good for you to write a plan down, because now guess what you have? Visually something to look at that tells you, I need two answers.
Oh, yeah.
Now here comes the fun part. You're gonna find out real quick why this is Prop Bob. I hope we finish Prop Bob in here. Well, I look at this, my number I start with, 7,864.3 cubic centimeters. There's a problem here. What is the conversion factor
Oh my goodness.
and the number and the unit for the volumetric of 1 mole of gas at standard temperature pressure? It's
Oh, wait.
22.4
Wait, I totally spaced out.
liters.
Yes.
What up? Yeah.
Will a liter cancel that out?
No.
No, that's cubic centimeters. Well, I guess we're stuck. What are we gonna do?
Convert
Give
to
a
milliliters.
Money conversion.
Hey,
Think.
It's
always got my trick, and this is the moment I pull it out. Did I look at you and say anything to you about this?
No. Yeah.
No.
No.
But what is this? This is equal to
milliliters.
7,864.3 milliliters.
Yeah.
We did it, guys.
This is why it's a trick of tricks, though. Because guess what happens here?
Oh, don't do it, Mr.
There
Hall.
are kids that just caught that trick, and now you're not going to catch the trick inside the trick.
What?
Stop
got
riddling me,
Stop.
Mr. Hall!
We gotta take it from
So many
milliliters to just liters now.
Let's go, Kenzie!
Yeah.
You gotta get this from milliliters to liters.
That's what I'm talking
They
about.
have to be the same unit. You
Thank
can't leave this as milliliters.
Stop lying to me.
We have to get that converted into liters so that we can do the conversion factor.
So,
So,
yeah.
let's set it up. 7,864.3 milliliters is equal to how many liters?
A few.
Here's the option.
A whole bunch. Mr.
Write the
Hall.
number down. 7,864.3 times 10 to the something another. We are finding the difference in the exponential value, right?
Yes.
So we have to find out what is the same between them is liters, so we don't care about those.
Care about him.
Liters means nothing to us, but the prefix milli does. What's the exponential value for milli?
I got this.
-3, we gotta find the difference, so we
H12.
have to subtract. What's the prefix over there on the right?
No.
Exactly, there is none. It's a base unit, which means exponential value of what? 0. So equals
-3.
-3. Is there an exponent on the units?
No.
No, so we do not multiply. Do I start with an exponential value?
No.
No. Here is my new number to start with.
Wow.
Now,
It's beautiful.
talk with me. What's your questions? Where you at? Because I know I threw a lot at you. There's a lot involved in this.
Can I come back and finish this at lunch?
Sure.
Let's say hypothetically, I jump the gun and I turn 7,864 into 7.8643.
Calculator reads it the same.
Okay.
Don't matter.
So if I had 7.8643 times 10 to the -6, that'd be right?
7.8643 times 10 to the -6? No.
No.
No, because you move the decimal this way, it's actually going to turn positive, it'd actually be 0.
You lying to me right now.
Because we have a race to the badminton today.
This is why I like to teach this method like this, so that we have it. Now, we have the new number to start with. Here comes the fun part. Let's start it.
Goodbye.
So we have 7,864.3 times 10
I'll take a
to the -3 liters
No, we'll come back.
of nitrogen. I set that over 1. Now, I'm starting at volume. I'm finally at a value where I can do something. So to go from volume to moles, what number am I going to have to use?
22.4 liters.
22.4 liters. That is the volume of 1 mole of gas at standard temperature and pressure. So I'm going to set the conversion factor up here to get me into moles. In order to do this, you can look at your not your periodic table, so sorry. You can look at your mole map, or the option you have, reason it out. Where am I leaving? What unit?
Volume. I mean,
I'm leaving volume, but what's the unit?
liters.
So is liters on the top or bottom?
Bottom.
Why is liters going on the bottom?
Because we're leaving it.
I'm leaving it and I need it to cancel.
Dropping it.
You gotta get it out of there. Mr.
So liters of nitrogen. What goes on the top?
The 1 mole.
1 mole of nitrogen. I need to take pictures. They're going to come in and want this.
I think we should do plastic.
I think we should put uranium
Now,
in it.
what number goes with liters?
So bad. Say again?
What number goes with liters?
22.4.
22.4.
I knew that.
That is on your mole map if you need it. So I cancel liters of nitrogen out. Now, those have canceled out. I'm left with moles. I know last time that I had a third step, I will just set up another conversion factor. But here's the difference. This road branches. Since I have to go from moles to 2 different things, I actually want to get a number for moles here. You're going to see why here in a second. So I'm actually going to punch that in my calculator. Oh.
Better wait for me, Mr. Hall.
You got to keep up with my pace. I don't have to keep up with yours.
I will cry, Mr. Hall.
Sorry, it's a high standard in this room, Mason. You knew it when you signed up. Happy you're here.
I missed you, Mr. Hall.
I missed you. So we have 0.3511 moles of nitrogen. Do you guys get that number?
Yeah.
Okay, good.
I didn't expect it to be such a small number.
Here's how you go look at it. Moles are, we use moles to make small numbers, to make it reasonable to deal with.
I think small numbers are more intimidating than big numbers, because that makes me think I did something wrong.
Now,
Oh, well.
here's what we have to do. We have 2 different scenarios that we have to set up for, because we have 2 different areas that we're going to. First one I have, I'm trying to go to atoms. Second one I'm trying to go to is mass. Whenever you break this down and you look at this, you're going to use that number for both of them. That's the reason we went ahead and found the moles.
Quick question, Mr. Hall.
Yeah?
To make up, like, the study or whatever, can I just use random, like, numbers? Like, do this at home?
What?
To study, can he use random numbers at home to make
Yeah.
up questions?
As long as it makes sense.
Gotcha.
Mason, I'm gonna look at you and tell you, you probably shouldn't. I mean, I went to college for a long time and did a lot of this to, actually know what I'm doing. Okay, let's set up the easy one first. The easy one's gonna be atoms. Am I going too fast?
No, no.
Okay. Easy one's gonna be atoms. I'm starting at moles. Can I go from moles to atoms?
Yes.
Yes, you can go straight from moles to atoms.
Yeah.
Do this, I need a conversion factor. I'm leaving mole, so what goes on the bottom? 1 mole of nitrogen. On the top, I'm trying to go to atoms, so I have atoms of nitrogen. What number goes there?
6.022. Avogadro
Avogadro, I just want to let's see if we finish it out.
number.
6.022 times 10 to the 23rd atoms. Moles cancel out, leaves me with atoms of nitrogen. That'll give me the answer there. Here's the one that's difficult, which brings up one of my favorite tricks. I love this trick, and I keep this trick throughout the whole year. And there's 2 sayings you will hear inside this class, and kids know it once they've had this class. Number 1, once you learn it, don't forget it. Because number 2, all is fair game. So we set up for this another conversion factor. I'm leaving moles, so moles go on the bottom. 1 mole of nitrogen. And then I have grams of nitrogen. That's going to go on the top. Now, what you're typically going to see is you'll go to your periodic table and you will take the value of the average atomic mass on there. Except for my 7 friends. There is 7 of them, and I'm going to show you the trick to how to remember them on your periodic table.
Bye-bye, Kendall. Miss you. Oh my God, is he gonna video me?
What you're going to see is there is something called the 7 diatomics. Here's the trick to memorizing them. The first one's the hard one. It's hydrogen. He's all by himself.
Yeah.
Then the other 6 make a 7 on the periodic table starting at 7. What do you mean, Mr. Hall? Go to atomic number 7, which is nitrogen. And you're literally making a 7 on the periodic table. So it goes through nitrogen, oxygen, and fluorine. Then we come down to chlorine, bromine, and iodine. As you can look on here and see, it makes a 7 on the periodic table. This is all this means for you. If I use the element name, it's bonded to itself. It's one of the 7 diatomics. You have to double the average atomic mass. So the average atomic mass of nitrogen is 14.01. That's not the number that we're going to use up there. We have to double it. Don't fall.
That's what I'm talking about.
So we got to find the molecular mass of nitrogen. There's 2 of them. We multiply it by its average atomic mass of 14.01 grams per mole. Give me 28.02 grams per mole. This number is what goes up here now. 28.02. Moles cancel, and it leaves me with grams of nitrogen. And then at that point, we're good to throw in a calculator. here are the answers we get. This is why I asked you if you wanted me to make this as hard as it can get. The 7 diatomics are a massive trick that I use. Those are the 2 answers you should get. While you're writing that down, I'm going to talk to you, especially because I have the camera on me. Here's the key. Look at the problem. Once you look at the problem, you see where I say a sample of nitrogen gas. That's the dead giveaway. I said the element name. I said the element name to hide the fact that it's N2, not just N. Don't freak out about this. Don't feel stressed about this. This was a massive problem. We will babyfy it and simplify it and make it easier tomorrow. Tomorrow when you come in, I'm going to break down and give you some notes on the 7 diatomics. And then we're going to kick up doing some mole conversions. We're going to do easy ones. We're going to build you up to this level to where you can do this. And trust me, you will be able to do this. Please have a great, wonderful rest of your day. I'm so thankful I got to have you today in class. Bye-bye.